Hello guys, so welcome to the last video in this RAG section. In this section, we are going to be building a system that is actually going to be production ready. So this is a system, okay, so I've called it advanced multi-step reasoning system. So before we go through the code, I'm going to show you the flowchart exactly how it looks like. Okay, so I know it looks a little daunting, but it's actually pretty simple. All right, so you can see we have the start node, and then we have this new node called the question rewriter. So let's look at what this actually is. Why do we need this question rewriter? Okay, so let's say we are going to be building this system for a gym. Okay, so let's say the name of the gym is going to be Peak Performance Gym, and an end user of the gym is going to come on their website and ask this particular question: what are Peak Performance Gym's hours? Okay, so in this case, what's going to happen? What do we normally do? We take this particular user query and then we send it to the retriever. The retriever is going to go and fetch all of the results, and then along with the user's question and the context, it's going to go to the LLM and it's going to respond with an answer. Pretty good. Okay, so this works perfectly fine. But let's say the user asks a follow-up question like, what about weekends? So in this case, we cannot actually use this particular string alone and, tell it to the retriever to go get chunks, because this alone does not make any sense. It can only make sense along with the entire context of the conversation history, right? So if you look at this and this together, this makes sense, but this alone, it does not make any sense, right? So in this case, we have to rephrase this question a little bit so that all the context is contained in this thing, so that the retriever has enough information to go and fetch the relevant queries. Okay, so basically without rephrasing, the follow-up query, this query lacks context on its own and would likely return irrelevant results if sent directly to the retrieval system, right? So the rephrasing node basically, okay, what this does is it transforms this what about weekends into what are Peak Performance Gym's weekend hours. So that is why we have this node at the very start. Okay, I hope that makes sense. So after this, we have the classifier. Very simple. This we've already seen before. So what does this do? It's basically just going to see if it is an off-topic query or an on-topic query. Okay, so we don't want our system to answer user questions when the user is asking something about random things, right? So in that case, it's going to go to the off-topic node and then go to the end. So there we can just provide a boilerplate response like I cannot answer this question. So something very simple there. But in case it is an on-topic query, so in this case, we are then confidently proceeding forward with fetching the chunks from the vector store. So that is what this retrieve node is going to do. Okay, so it's going to go and fetch, like, we can set k is equal to 4. In this case, it is going to fetch 4 different chunks, right? So right after this retrieve node, so we have 4 different chunks. So what this retrieval grader is going to do is it's going to go through each of these different chunks, and it's going to check if that chunk is relevant to the user's question. Okay, so since we said k is equal to 4, 1 or 2 chunks might not even be relevant, right? So we're just like checking, we're just grading each of those chunks. Okay, is this relevant or not? Is this relevant or not? Is this relevant or not? So there is a couple of different edge cases that might come up. So there might be a case where at least one node is actually relevant and the LLM can use it to answer the user's question. So in that case, we are going to go to the generate answer and then end it. But there is another use case. What if not even one query is actually relevant to the user's question? So in that case, we are going to go to this refine question node, and this is going to refine, it's going to add more information to the question. It's going to, change it up and make it better so that it is going to give more information to the retriever, and maybe some better chunk is going to be retrieved from the vector database. Okay, so again, we are going through this, there might be situations where, no matter how much we change the question, relevant chunks are just not being retrieved. In that case, we're just setting a limit to 3 different loops. Okay, so we don't want it to go for, infinity. That's going to blow out all of our tokens. So in that case, we just set the max limit to 3. In case it actually fetches something that is useful, in that case, we are going to go to this node, or else we are going to keep on looping through it. And if the 3 is reached, if the limit 3 is reached, it means that, it is a hopeless question. We cannot answer it. In that case, we are going to go to this cannot answer node, and that is just going to say, I don't have this information right now, or something like that. Okay, so or we can also like since it is still on topic, we can actually route it to a human agent and do something like that in this particular node. Okay, so this is what we have. We have cannot answer, generate answer, and then refine question, and this takes care of all of the different edge cases that we might potentially come up, in production. Okay, so I hope that made sense. I hope this introduction made sense. Let us now jump into the code and go through the code. Alright guys, so you can see that I've already gone ahead and I have created this file called advanced multi-step reasoning. So this first code block is going to be no different. So I'm just going to reuse the same examples that we saw. So we have the peak performance gym. Okay, so we have five different documents. Great. Okay, so we are initializing the DB as well as the retriever. Perfect. Okay, so coming down, we are initializing the model here. We are using GPT-4o, and then in this template, this time we are going to write, okay, so we are saying answer the question based on the following context and the chat history, especially take the latest question into consideration. Okay, so this time we are providing the entire history, the conversation history, okay, in the final LLM call that we make. And then we are going to provide the context as well. This context is going to be the retrieved chunks by the retriever. And then we have the question. Okay, this could be the rephrased question, that we make. Okay, so we are keeping this template ready. Okay, and then we are creating the RAG chain. Okay, so this is actually repeated. We don't want it to be repeated. All right. So we have the RAG chain coming down. So this is where we have the agent state. We are defining the agent state. So you can see there's a lot more properties that we are going to be maintaining to achieve this particular system. All right. So first thing, messages, right? So list of messages, we need this, right? So to maintain the conversation history, we need to maintain all of the messages. Great. So we have the documents. What does this use for? This could be all of the documents that are retrieved by the retriever. And then this could be the Boolean. Okay, this could be like, yes or no. Is the user's question on topic or off topic? The rephrased question, the question that the LLM, we can rephrase it if it does not really, contain the full context. So in that case, we are going to rephrase and put it here. And then we have this proceed to generate as well. So why would we want this? So if I come down here, so you can see that, if proceed to generate is true, in that case, we can just go to this particular node and then end it. If it is not ready, in that case we might have to refine it, or in case that the count is reached, we might have to go this route. All right, so that is why we might want this. So this rephrase count, again, this looping. Okay, so if it is more than 3 or something like that, in that case we might have to exit out of the graph, right? And then this is going to be the original latest user's question as well that we are keeping. So we have the rephrased question and the original question. Okay, so I hope that makes sense. Coming down, we have the grade question pedantic model. Okay, so I hope that you know why we use a pedantic model. So this pedantic model can be used to get structured data from the LLM. So in this case, what data that we want is going to be this. We just want a score. Okay, so the score is going to be a string, and we are giving the description. Is the question about the specified topics? Okay, so if yes, then return yes. If no, return no. Okay, so this is going to be the pedantic model, which we will soon use. We will soon use it down here. So yeah, let's now look at the question rewriter node. Okay, so let's look at this first node. Okay, all right. So we're just entering question rewriter with the following state. So you can see that at the very start, we are resetting a lot of these state variables. So we are resetting the documents, we're resetting on topic or off topic, we're resetting the rephrased question, proceed to generate or rephrase count. Okay, so why do we do that? If you can imagine, for every single prompt, every single question the user is going to ask, the graph is going to run from start to end. Okay, for the second question, it's again going to run from start to end. Okay, so we are going to be using a checkpointer as well. So it's going to remember what happened, but still it's going to start from start to end. So if there's a second question, we want to reset all these different things, right? We want to start the graph fresh. I mean, with the memory, with the conversation history, of course, but the rest of it, we want to start it from scratch. So that is why we are going to set all the state variables except for question and messages. Messages we don't want to remove, right? Because we want the messages to continue forward, right? All right. So coming down, so right here we're checking if the messages is not in state or messages is not there, which is going to initialize it to an empty list. If we provide the proper initial states, all of this would not be needed, but I'm just going to make sure that every edge case is handled and it is actually robust. So coming down, we are checking if the question is present in the state, if the question is not really present in the list of messages, in that case, we are appending to the message list. Now, so we're checking if the message list is greater than 1. Okay, so if it is greater than 1, it means that the graph has already run the first time, and now it could be the second or the third or the fourth time, right? So in this case, we might actually want to rephrase the user's question properly. Okay, so coming down here, else if the graph is actually running for the very first time, if the conversation is actually like, just starting, in that case we don't need to rephrase any question. In that case we can just like put the state question right here. But in case it is the second or the third, we might actually want to make sure that the user's question has the full context. Okay, so we might want to rephrase it. So that is why we are coming into this particular block. So coming down here, you can see that we are looking at the entire list of messages, and then we are extracting everything except the last message, except the last human question, right? So we have the conversation history right here, and then we are also taking the current question, and then we have a list of messages. In the system message, we are saying you are a helpful assistant that rephrases the user's question to be a standalone question optimized for retrieval. So along with the system message, we also have to provide the past conversation history as well as the last human message. Okay, so that is what we're doing here. So we are providing the past conversation history as well as the latest user question. Okay, and then finally we are invoking it. So in this response, we are going to get a rephrased question. Okay, so that question is going to be rephrased with a lot more context. So we are going to do response.content. We are going to strip it all of, all the unnecessary spaces, trailing spaces, initial spaces, and all of that. Okay, just to make sure that, everything is looking tidy in the production. And then we are going to just like print it out and then set this new, better rephrased question to this initial state. Okay, great. So we are now done with this question rewriter node. So what is the next thing? So right after the question rewriter node, we then have to look at the prompt, look at the question, and then check if it is still on topic or off topic. So coming down, okay, so I'm saying that you are a classifier that determines whether a user's question is about one of these following topics. Okay, so it needs to basically be about the gym, right? The gym history, founder, operating hours, membership plans, fitness classes, personal trainers. Okay, so if the question is about any of these topics, respond with yes, otherwise respond with no. Okay, so we need a very structured output in this case, right? So we need a clear yes or no from the LLM for this particular node. So I'm providing the user's question, okay, in the human message, and then I'm creating a prompt out of it. Okay, so I'm providing the system message and the human message right here. Okay, and then before I actually just send it to a normal LLM, I'm not interested in that, because I now want a structured output. I want it to be in this particular structure. I want a score property and a particular value, yes or no. Okay, so I'm going to make use of the with structured output method. So now I can pass it inside of this and then expect to get the exact score, and I'm also going to make sure to strip every trailing spaces, etc., and then I'm going to assign it to this on topic property in the state. Okay, so now this is going to be either yes or no. So coming back to the diagram, so if it is no, in that case, okay, it is not on topic. In that case, it's going to go to this particular node, or else it's coming here. So we need some sort of like a router, right? So that router can actually direct, the direction, the flow of the graph. So that is exactly what we have right here. So we have the on-off topic router. Okay, so we're entering this thing, and then we're just going to take that on topic. Okay, if it is yes, we have to route to the retrieve node, or else we have to route to the off topic response. Okay, so we have to go to the retrieve node or the off topic response. All right, so let's look at the retrieve node. So what should this retrieve node do? It is all that it's going to do is invoke. It's going to provide this rephrased question to the retriever, and then we now have the list of documents, and then so I'm just going to set it to the documents property in the state. All right, perfect. So what's the next thing? So let's come back to the diagram. So right after the retrieve is done, we now pass it to the retrieval grader. So this grader is just going to, return true. Basically, we have like, let's say 4 different chunks. It's going to go through each of those chunks, and then it's going to say true or false. Okay, is it good enough or not, right? So we need a structured output for that as well. So that is what I'm giving right here. We have another score. Okay, so in this case, if the document is relevant to the question, say yes. If not, say no. All right. So here I'm saying you are a grader assessing the relevance of a retrieved document to a user's question. Only answer with yes or no. If the document contains the information related to the user's question, respond with yes, otherwise respond with no. Okay, so we are again going to be using the structured output method so that we can actually force the LLM to use this particular tool to output in a structured way. All right, so now that we have the structured LLM, the supercharged LLM with the tool, okay, now we just need to loop through all of the documents that have been fetched in the previous node. So we have the doc right here, and I'm just in the human message, I'm just saying, okay, this is going to be the user question, and this is going to be the retrieved document. Okay, so we have the current document, we're just providing the page content. We don't really want the metadata, the source, we're just providing the page content. Okay, all right, coming down. So this grader LLM, it is either going to return yes or no. We're just checking that. So if it is yes, in that case, we are going to append it to the relevant docs. So we are creating a new list. Okay, so we want to create a new list, and we only want to keep the relevant things alone. So we are going to append it right here. So once this looping has been done, we're setting the new renewed qualified list of chunks to the documents again. And then we are going to, check whether we need to proceed to generate or not. Okay, so if the relevant docs at least has one relevant this thing, we can then confidently go ahead and go to the generate answer, right? So that is what we're checking right here. All right. So what's the next thing? We now have the proceed router. Okay, so basically to check, do we have to go here, or do we have to go here, or do we have to go here? So we need some, router right in the middle, and that is what we have right here. Okay, so we're entering the proceed router, and then we are getting the proceed to generate. So if this actually at least has 1, okay, it's greater than 0, in that case, we can go ahead to the generate answer node. But in case proceed to answer is false, and the rephrase count is already greater than 2, in this case, okay, maximum rephrase attempts have reached, cannot find the relevant documents. Okay, so now we have to go to the cannot answer node. Okay, so we have to go to this cannot answer node. And then we also have the final case. If both of these cases, like the rephrase count is still less than 3, at the same time the proceed to generate is false, in that case we have to refine the question. Okay, so this is how we refine the question as well. So if you see that, we are getting the rephrase count. Okay, so if it is, again, we're just writing the same logic here. And so we're taking the rephrased question, and now in this new system message, we are saying you are a helpful assistant that slightly refines the user's question to improve the retrieval results. Provide a slightly adjusted version of the question. Okay, so the human message is also going to be like, okay, this is the original question, provide a slightly refined question. So we're providing that, we're creating a prompt, and then we're invoking it, and then we're stripping it and getting the content out of it. So this is now going to be the refined question that we are updating the state with. Okay, so the rephrased question we are updating in the state. Okay, and the count we're also incrementing as well. Okay, because we don't want to loop through it, more than 3 times. And then finally, if everything goes well, if at least there is one chunk that is relevant to the user's question, we want to go to the generate answer. So we need 3 different things we need to provide, right? So we need the we need the conversation history that we need to provide to the LLM. We need to provide the rephrased question, the actual question that the user wants to know, and then the documents, the retrieved chunks. Okay, only the relevant qualified retrieved chunks from this documents state. So we're going to provide all these 3 things in this RAG chain. So if you remember this RAG chain, we're coming up here. So you can see that we are providing the history, we are providing the context and the question, correct? Okay, so let's go down again. Okay, so we are providing all these different things and we are getting a final response, and whatever response we get right here, we are just going to show it to the user because we are coming to an end. Okay, so before that, we are just going to update the state as well. The history always keeps on updating, right? And then we have the cannot answer node. Okay, if the retriever still cannot fetch the right chunks for some reason, or the documents are not really enriched properly, in that case we are coming to the cannot answer node. Here I'm just going to add this AI message saying that I'm sorry, but I cannot find the information you're looking for, and then again we are going to end the graph. Okay, so we've looked at the generate answer, we've looked at cannot answer. Now we can look at the off-topic response. This is something that we've already written. We're just saying, I'm sorry, I cannot answer this question because it is off-topic, right? And that is it, guys. That is it for all of the nodes. We've defined all of the nodes. The next thing is we just need to, so coming down, we are using the check pointer. So why do we need a check pointer? So the user needs to be able to, ask follow-up questions and all, right? So in that case, all the state needs to be, remembered. So because once, for every single question, we're going to run through the graph completely from start to end. So it needs to remember what happened in the previous run, right? So that is why we need a check pointer. We are using a very simple memory saver. And now we are just adding all of the nodes. Okay, so all these nodes that we've defined, we're just going to add all of it. I've used the same names as the node names, right? Okay, so whatever the function name that I've used the same things everywhere. And then I'm going to add the edges as well. So the question rewriter has to go to the classifier next, right? It needs to go to the classifier. And as soon as the classifier is done executing, we need to route to retrieve or off topic, right? And then there's another condition here for, right after the retrieval grader is done, there is another routing here as well, and that takes care of that. So coming down, there's a bunch of different edges that I'm adding here as well. So these are something that we would have seen a million times by now, but yes. So finally, I'm going to compile it, provide the check pointer. All right, perfect. So this is going to take some time. So because there's a lot of different nodes that we've written, it's going to take some time. All right, perfect. So you can see that it almost took me 1 minute and 10 seconds. So yeah, this is the same graph that we saw in the slides. So we have the question rewriter, classifier, retrieve, and then we have all these different edge cases handled as well. All right, perfect. So this is what I'm going to do. So first off, I'm going to check the first edge case, which is going to be what happens if the user asks an off-topic question. Okay, so in this case, the user is saying, what does the company Apple do? It's completely unrelated to the actual business, the gym business, right? So in this case, if I run it, so let's look at what it is saying. So it is saying that entering the question rewriter with the following state. Okay, so since there is only one state right now, one item in the list right now, it's not going to rewrite anything. And then it's coming to the question classifier, right? This classifier is saying the on topic is no. Okay, so this classifier is saying the on topic is no. In that case, it needs to go to the off topic response through the router that we had right here. Okay, so it's coming inside of the router. The router is directing the graph to the off topic response, and that is exactly what we see right here. So the AI message is saying, I'm sorry, I cannot answer this question. Perfect. So we can also see that the on topic is no, and then the proceed to generate everything is false, right? Okay, perfect. So let's look at another case here as well. So in this case, I'm going to ask something, what is the cancellation policy for peak performance gym memberships? Okay, so what is this edge case? So this edge case is, if I scroll up in the documents, there is absolutely nothing that is present in the document that talks about cancellations at all. Okay, so there is nothing about cancellations in this case. So it is still on topic. Okay, so it is still on topic, but at the same time, the retriever is not going to retrieve any relevant chunks at all. So it's actually going to loop through 3 different times and it's going to give up. Okay, so that is what this case is going to be all about. So let me actually run this. You can see that I've already I've gone ahead and used a different thread because we don't want to confuse everything in the same thread. So if I run this, okay, great. So let us see what it's saying. So right here, okay, so this is going to be the rephrased question. Okay, great. And then the on topic is also going to be yes, right? So coming down, it's going to retrieve 4 different documents. So this retrieve node is going to retrieve 4 different documents, and then the grader is going to kick in. So let's see what the grader is doing. So the grader is looking at the first chunk and the result is no. Okay, so this chunk does not answer the user's question. This chunk does not answer the user's question. No, no, no. Okay, so now it is actually going to, the proceed to generate is also set to false. So it is actually going to loop back. Okay, it's going to loop back to the retrieve. Okay, with a different question. Okay, with a refined question. So in this case, the refined question is going to be, what is the membership cancellation policy at peak performance gym? Okay, so you can see that it changed it a little bit. So here it is, what is the cancellation policy? Here it is what is the membership cancellation policy? Okay, so it basically made it a little better. So coming down, it is again going to retrieve 4 different documents. The answer is still no, 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 because we don't have any documents to support that. Okay, so finally what happens after like 2 different iterations, it is the proceed to generate is still false. So it's not going to come in here. It has already exhausted the looping as well. So now it is going to go to cannot answer. Okay, so it is going to go to cannot answer, and then it is going to end it. Okay, so we have the I'm sorry, but I cannot find the information you are looking for. So let's look at the third edge case. Okay, so here, okay, I'm using another thread. So this is going to be a new conversation. So the user is saying, who founded Peak Performance? Okay, so this is something that is relatively very easy. And if I come up here to this thing, you can see that Peak Performance Gym was founded by former Olympic athlete Marcus Chen. Okay, so this is easily answerable. So coming down, so this thing is easily answerable. But let's say the user actually asked a follow-up question. When did he start it? Okay, but this query alone does not have a lot of context. So we need to rewrite it with the previous question in the context, right? So let me run this thing. Okay, so in this case, great. So the first time it retrieved 4 documents, and then this about chunk is going to be yes. So this is actually a relevant chunk, right? So in this case, it's going to proceed to the generate answer node, and then the final answer is going to be Peak Performance Gym was founded by Olympic athlete Marcus Chen. Okay, so this is correct. So let's now run this. Let's use the same thread ID as this thing, and then let us now run when did he start it. So now what would happen is that this question rewriter is going to kick in. It's going to rewrite the prompt properly. Okay, so that this retriever has more context, because it is kind of dumb, right? So if I run it right now, okay, so the question rewriter. So you can see that the rephrased question now is going to be, when did Marcus Chen start Peak Performance Gym? Okay, so it's not going to be he anymore. It's going to be Marcus Chen. Okay, so in this case, again, it's going to retrieve 4 different documents. Okay, Peak Performance Gym was found. Okay, it's going to fetch this thing, and then finally we have the generated response. It was in 2015. And that is it, guys. I do hope that you learned a lot. Do pull the code and run it by yourself, and I will see you in the next section.